Hello friends, we study the chapter units and measurement. I am from RBNB College, Rampur. My name is Aher. Now we study the remaining part of this chapter. Now we start the significant figures. What is the significant figure? The number of the digits in the measurement of physical quantity about which is certain. The first one is about which are not certain. This is known as significant figures. Now, rules for significant figures are all the non-zero digits are significant. For example, suppose we have the number 178.43, then these are all the non-zero numbers. Therefore, significant figures are 1, 2, 3, 4, 5. Therefore, 5 is the significant figure. Suppose we consider another example, that is 4, 3, 2, 5. These are all the non-zero numbers and the significant figures are 1, 2, 3, 4. Therefore, 4 is the significant figure. Now, the next rule for significant figures are all the zeros between the two non-zero digits are significant. See the example. Suppose 165.02. Now the zero is in between these two non-zero numbers. The zero in this case is significant. Now the significant figure is 1, 2, 3, 4, 5. 5 is the significant figure. Now consider another example. Suppose 1009. Now in this case significant figures are, see, suppose this is non-zero number, this is non-zero number, and these are the numbers, these are the zeros in between these two non-zero numbers. All these are the significant. Therefore, significant figure for this number is 1, 2, 3, 4, 5. 5 is the significant figure. Now next, if the number is less than 0 on the right hand of the decimal point are significant, while the left of the first non-zero digits are not significant. See the example. In this example, this is the decimal point. Now these are the zeros towards left and this is the zero towards right. These are not significant, these are the significant. Therefore, significant figure for this number is 1, 2, 3, 4. Therefore, 4 is the significant figure. Now the next rule, the zeros of the right of this are the significant. That is, consider the example. Suppose 1500. In this case, these zeros are significant. Therefore, significant number is, or significant figure for this example is 1, 2, 3, 4. 4 is the significant figure. Now consider this number, that is 0.645 into 10 raised to 7. In this case, this 1, 2, 3, these are the significant figure. Now we see the some examples. Suppose the numbers are numbers and significant figures. Now suppose the number is 183478. The significant figure is, suppose 1, 2, 3, 4, 5, 6. 6 is the significant figure. Then suppose 162008. In this case significant figures are 1, 2, 3, 4, 5, 6, 7. 7 is the significant figure. Suppose there is 0.018. In this case, 2 is the significant figure. Then 184300. In this case, the significant figure is 5. These are all about the significant figure. Now we see the next topic, that is order of magnitude. Order of magnitude, that is the magnitude of any physical quantity can be expressed as a raised to 10 raised to n. Then order of magnitude is equal to a into 10 raised to n. This a is in between, it is greater than 0.5 and less than 5. Then this n is called as order of magnitude. Consider the example. Suppose radius of earth, it is 6400 kilometer. Then we can convert it is into the meter, that is 6400 into 10 raised to 3 meter. Then we get 6.4 into 10 raised to 6 meter. Then again this a is greater than 5, it is converted at 0.64 into 10 raised to 7 meter, and the order of magnitude is 7. Order of magnitude is 7. Suppose the electric charge, it is suppose 1.6 into 10 raised to minus 19. In this case, the n is equal to minus 19, it is the order of magnitude. This is all about the significant figures and order of magnitude. We see some examples. In Ohm's experiment, the values of unknown resistance, is 6.12 ohm, 6.09 ohm, 6.22 ohm, 6.15 ohm. Calculate the mean value, mean absolute error, relative error, and percentage error. Now see, we solve this example. In this example, the Ohm's experiment is performed and the resistance is calculated, the values of resistance, the readings are, now suppose A1 is equal to 6.12 ohm, A2 is equal to 6.09 ohm, A3 is equal to 6.22 ohm, A4 is equal to 6.15 ohm. These are the 4 readings. Number of readings are 4. Therefore, we can say that number of readings are 4. We find the mean value first. Then first, mean value. Mean value is, it is the arithmetic mean of this reading, that is A1 plus A2 plus A3 plus A4 divided by 4. Substitute the value, we get 6.12 plus 6.09 plus 6.22 plus 6.15 divided by 4. Add this number, we get it is the sum of, that is it is 24.25 0.58 divided by 4. Perform the addition, then you get the addition, that is 24.58 divided by 4. Again divide by 4, we get 6.145. Then now this 5 is greater than 5, this last figure is greater than 5, we can add it is into this and we get it is 6.15. That is mean value is 6.15 ohm. Now we find the absolute error. Absolute error. First, that is AM, absolute error is difference between mean value and each individual error, and it is the magnitude, that it is positive. AM is the, suppose it is 6.15 minus the first reading is 6.12. It gets 0.03. That is, we get 0.03. It is the absolute error in first reading. Now in next reading, that is AM minus A2. The second reading is 6.09. 6.09 minus 6. Suppose this is 6.15. 6.15 minus 6.09, we get the value, it is 0.06. Then third reading, that is AM minus A3. It is 6.15 minus 6.22. 6.22, we get this is 0.07. Then it is minus, then this is the modulus, we get the positive value, that is it is 0.07. Now the fourth reading, that is AM minus A4, it is 6.15 minus the last reading is 6.15. We get 0 here and the answer is 0. Now these are the absolute error in each reading. Now mean absolute error. Mean absolute error. Mean absolute error is addition of this all errors, that is 0.03 plus 0.06 plus 0.07 plus 0.00. It becomes divided by 4. It becomes 0.16 divided by 4 and the answer is 0.04. It is mean absolute error. Mean absolute error. Mean absolute error is 0.04. Now we find the relative error. Relative error. Relative error. Relative error is ratio of mean absolute error to the mean value. Mean absolute error is 0.04 divided by 6.15 and the answer is 0.065. 0.0065 and the percentage error is equal to this relative error divided by multiply by relative error multiply by 100, that is this is 0.065 into 100 and we get the answer, that is 0.065. 0.065. It is the percentage error in this experiment. Thank you.